Hey everyone, this is lesson 7, concept development video. Today we're going to be working on multi-digit whole number multiplication. So an extension of the lessons that we've been doing the last few days. But instead of doing like 3-digit and 4-digit times 2-digit, we are going to bump it up by multiplying at least 3-digit by 3-digit and 4 digits by 3 digits. So we're going to make it a little bit more challenging today. So let's go ahead and get started. Let's start with 3 digits times 3 digits. Let me get a math problem for us. Let's do 524 times 136. 524 times 136. So we are going to be doing area model and standard algorithm. So let's go ahead and start with an area model. Well, one of the things that we're going to notice is we're going to have, I don't want to break, we're going to decompose the second number on the side. And we're going to do it just like we were doing before, but we need three places because there's three place values. There's hundreds, tens, and ones, right? So it's 136. And then at the top, we're going to go hundreds, tens, one, 524. Now inside of these, we can see each expression. I'm going to go ahead and quickly write each expression. Length times width for each one of these boxes. So when you get into these middle boxes, you have to really be mindful. And I'll use a highlighter real quick. You have to be thinking length times width and kind of do every box like that. Think about it like that so that you can know which expression you're working with. And if you take the time to set up all the expressions now, it'll be a little easier to solve when we work at the solving part. Then our brains can just be thinking about solving the math problem. Let me change the color of my pen so that we can see the difference of it. Well, I'm going to start up here in the top left. So I just underlined the box I'm starting in. 6 times 5 is 30. Well, we're talking 6 times 500, so it's two more zeros. 6 times 2 is 12. 2 tens would make it 120. 6 times 4 is 24. And if I added those together, 144. I did that in my head. If you need to stack them, you go ahead and stack them to get your partial product. 3 times 5 is 15. 10 times hundreds would equal thousands. So it's 15,000. 3 times 2 is 6. And then it would be 10 times 10 hundreds. 3 times 4 is 12. 120. So that would be 15. Right? 15,720. 1 times 5 is 5. 100 times hundreds will be tens of thousands. 100 times 2, 1,000. 52,400. Now, I just want you to remember, because we're going to connect this to standard algorithm, when we multiply by the ones, this part of the area model is showing where we multiplied by the tens and we had 1 0 at the end. And then this bottom one is multiplying by hundreds and we saw 2 zeros at the end. Okay, so I'm actually going to go to, let's shrink this so that I can work a little bit to the left of it. And now let's go ahead and try to solve this with standard algorithm. 524 times 136. Now, okay, so I'm not sending over on the left-hand side. We have to stack those and add those partial products. So I'm going to go ahead and line them up. Of course, I ran out of room on the screen. 4, 6, 11, 12, 7, 10, 11, So it should be, let me scroll down a little bit, 71,264. Okay, so let's go ahead and check that over here. Now, just like on the first last round, we multiplied 1 times the top number. I wanted to use the highlighter for that, but so 6 times 4 would be 24. Whoops, Mr. Big. I don't have my stylus, so I'm using my pen or finger. 6 times 4 is 24. 6 times 2 is 12, plus 2 more is 14. 6 times 5 is 30, plus 1 more is 31. Well, that one matched up with my partial product over on the left-hand side with my area model. I'm going to change colors for my tens. Now remember, when we shift to the tens place, we represent that we've moved to the tens place by putting a 0 and a 1, so we can start right in the tens place. 3 times 4 is 12. 3 times 2 is 6, plus that 1 is 7. 3 times 5 is 15. 15,720. That one matched up as well. Now, here I'm going to shift to orange. Now we went to hundreds on the area model. Now we're in the hundreds place on the standard algorithm. We represent 2 zeros for our hundreds place so that we can start in the hundreds place. 1 times 4 is 4. 1 times 2 is 2. And then 1 times that 5 is 5. 552,400. Then we can, they're already stacked for us so that we can add them. 1 plus 7 is 8, plus 4 more is 12. 3 plus 5 is 8, plus 2 is 10, plus 1 more, 11. 71,264, exactly what we had on the left-hand side. All right, let's go ahead and clean our boards off or our papers and try another problem. All right, this time we're going to be multiplying 4,519 times 326. Let's again start with the area model. So this time we're doing 4 digits times 3 digits. But let's go ahead and again start with the area model. Let's go ahead and put the second factor on the left-hand side, and we'll go from 1 to 10 to 100. And on the top, we'll do, well, we're going to have to do 4 places because it's 4 digits. So I'm going to have to make this area model bigger. And then 9. So I'm going to do 9 over here. Oops, that didn't look right. I was missing 1 line. 4 places across the top, 3 places going down the side. And then I'm going to go ahead and change the color so that I can easily see these math problems, these expressions. 20 times. Okay, let me pause this, and you guys go ahead and pause and finish this area model, and we will check each other. You can see that I'm just finishing my expressions, and then I'm going to also solve for those expressions inside of there, and then we can figure out the partial products together. So you're going to unpause when you have the area model completed, and we'll solve the partial products together. All right, take a few seconds to check your work. Make sure that your area model is accurate, and then we can start adding these up to get the partial product. Well, we might have to stack these and add these. And as you can see, this is why the area model is not the most efficient, meaning not the fastest way to do things. You have to actually do a little bit more work with these, with a few more steps to solve things. The area or the standard algorithm does all of this in one step, where we have to do multiple steps to get it. It makes those steps a little simpler because we're just working with our basic stack. $80,000 to $10,000. I just feel like it's been really flat. 1, 3, 5, 5, 7, 0, 1, 1,355,700. And now we still have to, now that we've done all that work, we still have to add these three pieces together. Whew, this is a lot of work. Let me shrink this down so I can actually let me scroll down. Let's see. I'll give myself some more room down below. Start with the largest number, 1,355,700 plus, and we're going to do 90,380. And we're going to add that to 27,114. And scroll down just a little bit more. 4, 9, 10, 11. 5 plus 7 is 12, plus 1 more is 13. 14, 2 more, 16, 17. 1,473,194 is the answer to that. Well, like I said, that's not the most efficient way. So let's try solving that using the standard algorithm so that it's a little bit more efficient. Let me change colors, and where there's 4,519. Oops, that's a bad X. Times, and what was our second number? 326. Go down a little bit more. And that's not going to have enough space. So let me actually, I'm just going to copy this and go to a new page. Bear with me while I get this down on the page. Pasting. Where's my mess from? Copy and paste didn't work, so we'll just have to rewrite it. All right. So standard algorithm. 1 times all the top numbers. So 1 times 6 times 9, 64. 6 times 1 is 6, plus 5 more is 11. 6 times 5 is 30, plus 1 more is 31. 6 times 4 is 24, plus 3 more is 27. Let's just go back to the last page and see if that was the same partial product. 27,114. Again, look at all in one step. We were able to do 1, 2, 3, 4, and then adding them all together, 5 steps in one. So that's why our standard algorithm is so much faster. All right, let me change colors of my highlighter. Now we're doing 10 times the top number. So now we're going to be in the tens place. Let's go ahead and represent the tens place with a 0 down below. 2 times 9 is 18. 2 times 1 is 2, plus 1 more is 3. 2 times 5 is 10. And then 2 times 4 is 8, plus that 1 more is 9. 90,380. Let's double check. 90,380. Again, saving us 1, 2, 3, 4, 5 steps to get 90,380, all in the same step. All right, over here, let's change colors of the highlighter again. This time we will use red to show it. Now we're in the hundreds place, and we're doing this hundreds times the top number. Well, now that we're in the hundreds place, let's go ahead and show that by placing 2 zeros down there to show that we're in the hundreds place. Now that we're in the hundreds place, 3 times 9 is 27. 3 times 1 is 3, plus 2 more is 5. 3 times 5 is 15. 3 times 4 is 12, plus 1 more is 13. 1,355,700. Double check it over here. That's exactly what it is. Saving us 1, 2, 3, 4, 5 steps. And then it's also already set us up to add them together stack and add. Oh, there's the copy and paste way down below. Silly Mr. Bird. All right, 4 plus 0, 0, 4. 1 plus 8 is 9. 1 plus 4, or 1 plus 3 is 4, plus 7 more is 11. 7 plus 5 is 12, plus 1 more is 13. 2 and 9 is 11, plus 5, 16, plus 1 more is 17. 3 plus 1 is 4, and then 1 more. 1,473,194. Let's just double check. Is that our answer down here? 1,473,194 in a much faster, more efficient method. My earphone just beeped, so I apologize if that beeped on your end too. Now, let's go ahead and do one just straight standard algorithm. Let's go ahead and do 5,498 times 376. Okay, remember first step, 1 times the top number. Oops, I'm doing it again. Let me just pause real quick and check my, yeah, 6 times 8 is 48. Times 9, 54, plus 4 more, 58. 6 times 4, 24, plus 5 more, 29. Times 5, 30, 2 more, 32. All right, now that we've finished with our ones, we can go to 10 times the top number. Now we want to make sure we represent our tens place with the 0 in the ones place so that we start right in the tens place. 7 times 8 is 56. 7 times 9 is 63, plus 5 more, 68. 7 times 4, 28, plus 6 more, 34. 7 times 5, 35, plus 3 more, 38. Make sure you cross off your regrouping like I'm doing so that you don't get confused. And you go to stack and add. Now our last spot is to do our hundreds times the top number. And to do that, we're going to represent zeros in the tens and ones place, so we start right in the hundreds place. 300 times 8 is 2,400. 3 times 9 is 27, plus 2 more is 29. 3 times 4 is 12, plus 2 more is 14. 3 times 5 is 15, plus 1 more is 16. Now we can add these up. 8, 14. 9 plus 8, 17, plus 4 more is 21, plus 1 more is 22. 2 plus 4 is 6, plus 9 more is 15, plus 2 is 17. 3 plus 8 is 11, plus 4 is 15, plus 1 more is 16. 3 plus 6 is 9, plus 1 more is 10. So we should have an answer of 2,067,248. All right, now let's go practice this on the problem set, and I'll see you over there. Nice job.